Hello and welcome you all. I am Dr. Anubha Jain, Senior Journalist at ETV Bharat. Today we are exploring a remarkable breakthrough from the Indian Institute of Science, Bengaluru, where researchers have discovered a quick and practical way to recycle one of the toughest plastics, nylon 66, commonly used in fishing nets and car parts. Joining us today is Professor Suryasarathi Bose from the Department of Material Engineering at IISc, whose team has developed this innovative 2-minute recycling process. Welcome, Professor Bose.
Thank you, Anubha.
To begin with, could you tell us about your work in simple terms and what inspired your team to take on the challenge of recycling nylon 66?
So, given that India has a long coastline and we have found that a lot of abandoned fishing nets on the coast every year, so this motivated us to take up this challenge because this particular polymer, although it's an engineering plastic with a lot of important properties which makes them ideal for this particular application like fishing nets or automotive parts, but it is one of the toughest to recycle them back. And that was the motivation. The motivation was twofold. One was environmental concerns and also economic opportunities. So environmental concerns because although it's an important material, but it is being destined to the landfill or is being abandoned at the coast after its useful life. So we thought, why not try to upcycle them into a value-added product that can be recycled multiple times or can be used in some other applications where it can be applied for. And economic wise, because we thought that if it creates an opportunity for the coastal community as a give and take, so this can also solve this problem because it not only affects the coastline but also the marine life and the ecosystem around it. So this
Okay,
was the
great.
motivation.
Yeah. So, how did the idea of using melamine as a cross linker in the recycling process come about?
So we screened many reagents and we found that melamine was one of the cheapest and its multifunctionality helped us in cross-linking polyamide 6,6. And that's the reason why we chose melamine. And what we found out that using a zinc-based catalyst, we were able to give nylon 6,6 a new life by cross-linking it. And the properties that came out or emerged out is far superior than the virgin nylon 6,6. So that was the beauty of using melamine.
Okay. So, you mentioned that the process take less than 2 minutes. So, how significant is the speed in industrial recycling?
So, see, chemical recycling often takes long hours and it also involves a lot of solvents, whereas our method was to use it in the melt stage. And
Mhm.
less than 2 minutes is very, very relevant to industrial operations because most of the industrial processes are of that time period. So, therefore, this technology can directly be applied to industrial upscaling. And the processes that are currently being used at industries also work with melts and also for very less time. So this rightly fits in there. Retrospectively, it can be fit in the industrial lines.
Okay, great. So, what were the biggest scientific or technical hurdles, challenges your team had to overcome while developing this method?
So there are a couple of challenges. One is the fishing nets that we could recover from the coastline is already contaminated with dyes. It could be salts, it could be biofoulants, and so on. So we have partnered with a company called Chine Polymers, which is a Chennai based, and it helps us in getting these fishing nets in a much clean and uncontaminated form. So we could then work on it to upcycle the fishing nets into value-added products. So that was the first challenge. Second was to find the optimum catalyst content. So we ran several optimization to find out which catalyst could be the best here. And the thirdly, the challenge was to see if it can be done at a speed which industry likes. So, for example, if it would have been a long time taking job, then many industries would not come forward and we tried to use industrial scale so that it can be directly translated to the industrial lines.
Okay, right. So, what makes this method more efficient compared to conventional recycling techniques?
So conventional recycling or the chemical upcycling techniques, as I said, takes long hours, involves solvents, whereas our technique only uses melt, so it is energy efficient, it is environmentally friendly, and so on. And what we have found out is melamine can not only give life to nylon 6,6, but it can be extended to other polymers like polyesters, nylon 6, and other engineering plastics which are often destined to landfill. So we can
Mhm.
actually give life to these engineering plastics and create materials that have better or improved performance than their virgin counterparts.
Okay, okay. So, sir, as you mentioned, the recycled nylon has been used to make products like benches, dividers, even a speed boat. So, apart from these, what are the other items made of recycled materials, and how durable and safe are these recycled materials compared to the original nylon or plastic?
Right. So as I said that I'm also a co-founder in Voila, and Voila is India's first 3D printing company which actually 3D prints recycled plastics into value-added products. So
Okay.
we have tried furniture panels. We have also showed that a small speedboat hull can be made out of these engineering plastics. We are extending this to road dividers and many more products, for example, trash bins and so on. So therefore, all the used nylon can therefore be used in value-added products. And through cooperation with Voila and other agencies, we were able to convert them into useful products.
Okay. I'm pretty inquisitive to know more about this 3D printing. If you can highlight how this 3D printing works, how
Right.
the printouts would be like plastic printouts, what it is about. Can you please elaborate?
So yes, so as I said, that Voila is converting waste plastics into 3D printed products. So it's actually you melt the polymer and you give it a shape, very similar to how injection molding or other processes look like. But instead, here the waste plastic directly is fed into a robot, and the
Okay.
robot has a small extruder fitted in it, which melts the polymer and gives a part a shape. So therefore, you have the flexibility in design, you have the flexibility in the model that you print. And only thing, or the only difference here is injection molding or molded parts are much
Mhm.
faster. And here it takes little time to print a part. For example, a chair can be printed in about 1 hour,
Okay.
whereas in 1 hour, thousands of chairs can be molded. So that's the
Mhm.
difference between 3D printing and molding. But 3D printing, of course, is a very unique way of upcycling plastics.
Yeah, very unique. So, how easily can this recycling process be adopted by existing industrial or municipal recycling facilities?
So that's the reason why we chose extrusion-based upcycling, because extrusion is one of the most lovable and most friendly way of handling plastics, where there are no solvents. So many industries have long extruder lines which convert plastics into various shapes. So we wanted to be around that processing tool, and that's the reason why we have chosen a melt-based upcycling method, which can be directly transferred to the industrial scales. And that was all about using melt-based processes so that it can be directly transferred to many industries which are already using extrusion lines for various other applications.
Mhm. Right, right. So, how big a problem is fishing net waste in India's coastal regions, and how can your method help tackle it? This problem.
So as I said, that India has a long coastline, and what we have observed is the awareness among the fishing communities is very low. And that's the reason why the fishing nets are usually abandoned at the coast. And what happens is when they're abandoned, they pollute not only the coast, but it also affects the marine ecosystem and the whole ecosystem around it.
True.
And we have found that tons of fishing waste nets are already scattered around the Indian coast.
Mm.
And our method, if it can actually incentivize the fishing communities to give and take so that they can, come back and give the abandoned fishing nets to us. We can convert them into useful products. This incentive can actually drive, revolution among the fishing communities. And by partnering with the fisheries department and the NGOs, we could collect back all the abandoned fishing nets and we can convert them into useful products and give them back to the society.
Very nice, sir. Wonderful. So, in what ways can this innovation contribute to reducing marine pollution and supporting a circular economy?
So as I said, that nylon 66 was one of the engineering plastic which was difficult to recycle, and that's the reason why fishing nets are being abandoned along the coastlines. So our technology has clearly demonstrated that there is a lot of value to these abandoned fishing nets, and we have been able to upcycle them with improved properties so that they can be now transformed into quite useful products which could be beneficial. So we may not be able to convert them back into fishing nets, but it can be converted into a speedboat or a furniture or a park bench along the coastline and so on. So this creates a local economic opportunity for the fishing communities, as well as we can protect our environment because these fishing nets eventually end up in the ocean, thereby affecting the marine life around it. And we have already heard about the effects of microplastics, in both terrestrial ecosystem as well as marine ecosystem. So we can
Mhm.
actually tackle both the problems with by upcycling nylon 66.
Okay. So, in continuation to this, I want to check, do you foresee any policy or industry collaboration to scale up this recycling method nationally or globally?
Yes, so a lot of collaboration is indeed needed here, not only from my startup Voila, which is also trying to see if it can be upscaled, whether we can use mixed nylon waste, nylon 66 waste, and so on. But we would definitely need some policies, some awareness among the fishing communities. We also need to partner with fisheries department and the local, fishing communities so that it would be an incentive to give back their abandoned fishing nets and so on. So this way we can solve a bigger problem in a much easier way, where if it is a give and take type of exchange that happens among the fishing communities, and of course, a lot of awareness is needed among the fishing communities, which we want to partner with NGOs.
Yes, exactly. So, bringing this innovation to market, what role does your startup while A3D is playing? What's the role?
So yeah, so Voila is a bridge to gap, it bridges the gap between the research that happens in the lab to the real world.
Mhm.
So when we partnered with Voila, we were quite fascinated that how the upcycled plastics could be actually converted into real world application. And with Voila, we could actually do techno-economical analysis. We could do a life cycle analysis of these engineering plastics, which
Okay.
otherwise was very difficult to recycle.
Okay, okay. So can this method be applied to other hard to recycle plastics beyond this nylon 66 or other tough polymers beyond PA 66?
Yes, so the melamine and the zinc chemistry that we have used can be extended to other nylons. It could be extended to polyesters and so on. And currently, we are actually trying this chemistry with all these different kinds of polymers to see if it is a universal approach or not.
Mhm.
Besides nylons, we have been working with polyesters, polypropylene, polyethylene, and also ABS type of plastics. And we have found that all of these plastics, which was often destined to landfill, can actually be converted into very useful products by the chemistry that we are using.
Okay. In the end, like to know what are the next step for your research or startup in this field? Your concluding note.
So we are now extending our strategy to mixed waste because sometimes you have fishing nets from different companies. So it could be a mixed nylon waste. So we are trying to see if it works for mixed nylon waste. We are trying to scale it up. So Voila is also helping us in scaling up. And we are also partnering with different companies like Chine Polymers to see if this can be extended in a larger way so that tons of the fishing nets can actually be recycled. So recycling 1 ton of fishing net means that much amount of virgin plastics can be avoided, that
Mhm.
much amount of microplastics can be avoided into the ocean and so on. So we are partnering with several industries to make sure that this technology reaches to every corner of the coastal communities.
Okay, right, sir. Thank you so much for your time.
Thank
And
you,
with the
Anubha.
world producing more than 430 million tons of plastic every year, fishing waste is a major threat to marine life. So, this new method, I believe, would offer a smart, eco friendly way to turn discarded fishing nets into useful products and giving plastic a new life and helping clean up our oceans. Thank you so much, Bose, sir, for this insightful information. Thanks a lot.